Hi gents, here comes theorem 19. This is one that they love to ask this particular question. So I would know this one well. And what it says is, okay, it's a long one. The angle at the center of an arc is maybe, how will I rewrite it? Yeah, the angle at the center, no, it's not the center of the arc, it's the center of a circle, yeah. Standing on an arc. Is twice the angle at the circumference while standing on the same arc. Okay, let's go and have a little look at that. What do they mean? Because the language is tricky. First off, create an arc. Okay, an arc is like that thing there. Okay, so it's just that little length that you have going on there. I might do this bit in green. Okay, so that's the arc part. It's of course the blackened bit. So there we go. What it's saying is, if you go to the center and if you join that arc to the center of the circle, you'll get a particular value. But if you go and join it somewhere else in the circumference, let's say up here, okay, if you join it up there, I'll make this a bit bigger, what you'll find is that whatever value you add in here will be twice so that's the angle, just if you read the question, that's the angle at the center that you created. It will be twice the angle at the circumference that you've made there. This is something, in fairness, that you have seen before. We've done it before. Just a quick reminder of the things that means. Sorry. So if this thing is 100 degrees, that thing is 50. Okay, we can say that. What it also means is, if we were to join another one there, we would have automatically that one would be 50 as well. So in fact, you don't even need the center. If you just have an arc and you join it there, and if you join it anywhere else, okay, like over there, this will immediately be that. And not only that, it also follows that these two are the same as each other as well, because the arc, if you turned your head upside down, that would become an arc, and you'd have the exact same thing going on. Okay, but that was stuff that we've done, but you know, it's been a while, so worth just refreshing whenever we mention it here. Okay, this is what it means, and now what we have to do is we have to go and prove it. So let us first of all draw the diagram, and as I say to you always, the diagram is the key to remembering this. So the first thing we need to do is we need to draw a circle. The next thing we need to do is, if you draw a line through the center and down a little bit further, and now just draw, it's like one of those peace signs, now draw in two triangles like that there. Okay, so we're going to give these things labels. We're going to call it X, Y, Z. We're going to give the center of the circle, we'll call it O for origin really, more than anything else. And we'll call this thing W, just to be able to say that we went from there to the end of it. And what we're also going to do is we're going to stick in, we're going to label some angles and give them names. Okay, the names I think that we should give them, we'll say alpha, we'll say beta, we'll say gamma, we'll say delta, delta, and we'll say epsilon, like that. Okay, those are actually the only angles that you need inside the whole thing in order to be able to do it. So first of all, let's, I suppose we can write it out here. We can say, what is it that is given to us? So given, okay, given is circle, with a center. It does mention the center. It's center O. Okay, that bit's mentioned, and what we also should mention is we should mention the arc. So also given to us are the points. Well, the points that are given are 0, but the points also given are x, z, that's the arc, and sorry, that's not, y, z is the arc, and also x is mentioned because it says at the circumference, so that's our one up at the circumference there. Okay, so that's given to us. Construction is anything that we added. Construction is anything else that we've gone to add. I suppose what you can, no, I in fact I would write it in under the construction here, I think. So the construction is, as they say, produce. It's a nice word. Produce XO, that line segment, to W, as in keep it going through there. So that just means extend XO out to W, which I think produce is a nice word for it. And we're going to label the angles as well. So label alpha, beta. They don't specifically mention alpha and beta. I know that that's used, but they didn't say this one and that one. They didn't mention the whole thing, all right. They didn't mention alpha and beta individually. Gamma, delta, and epsilon. So we got to label all of the angles, indeed. Okay, this one is another congruent triangle question. Okay, it's another congruent triangle question. What do we want? First of all, it is to prove, so we should say that. So to prove, we want to show that if we add alpha and beta together, okay, that's our angle at the center, and if we have delta and epsilon and we add them together, now how can we make them equal to each other? Remember, the angle at the center is twice what it is at the circumference, so we need to take d plus e multiplied by 2 in order for them to be equal. So that's the proof that we are trying to come up with. We want to show that this thing is the case. Okay, our proof, as I said, congruent triangles. Proof. Okay, first thing to say is that alpha is equal to delta plus gamma. Why? Pause the video, have a think about it. It's actually something that we did relating to a previous video. Okay, if I draw this in here, if this is gamma, and that's it, and the one on the top is delta. Remember what we said, if we take part of our triangle and we draw it on, we create an external angle. And the external angle is equal to the two interior ones added together. So alpha here is equal to that, and the reason we would give is exterior angle. I've been using shorthand for it, which is fine to do there. You can do that as well. So that is an exterior angle as done there. Okay, what else can we say here? What we can say is that we are dealing with we are dealing with what are they called when you've got two sides the same? Do you remember? It's an isosceles triangle. So it turns out that OY is equal to OX, and the reason is that it's an isosceles triangle. Well, actually, you know what? That isn't a good reason. I can't just state that it's an isosceles triangle, so come up with a better reason why that's the case. What's your reason? Okay, the reason is that they are both radii, both radiuses. So they're both radii, they're both the same length as each other. Okay, and what that means is, it means that gamma is equal to delta, because that's the reason. That's an isosceles triangle. We've now proved it's an isosceles, so we can say that that is the case there. So actually, now that I think about it, this is not going to be with congruent triangles. I can see the plan forming in front of me here. What we can say here is that since we had alpha is equal to delta plus gamma. But since gamma and delta are the same as each other, what you can actually do is you can replace gamma with delta. So instead of saying delta plus gamma, well, since gamma is the same as delta, I can say it's equal to delta plus delta. So we have now that alpha is equal to 2 deltas. Okay? What you would now say, I'm going to start writing it over here. What you would now say, my favorite word in maths, similarly, meaning we don't have to do all the same thing again, but we could if we wanted to, we don't. Similarly, it must be true, therefore, that beta is equal to 2 epsilons. Yeah, so just having a moment where I was going through the Greek alphabet, alpha, beta, gamma, delta, epsilon. Yeah, I think that's right. Okay. Well, look, what can we say? What can we say now? It turns out that alpha is 2 deltas and beta is 2 epsilons. So what we can say now is we can say that alpha plus beta, if we add those two things together, it would be equal to 2 of these things added together. And it also follows that if we factorize out the 2, we get the exact thing that we wanted. Okay, so we've now found that when we add these two together, it equals to the other 2, but only when they've been multiplied by 2, i.e. that the angle alpha plus beta is twice the angle delta plus epsilon. And I think we deserve a little QED on that one. That one is one of the tougher ones, is what I would say by a long shot. Okay, gents, thanks.